morning, dear students. In the last lecture we have seen the derivation of electric field of an electric dipole at an point on the axis. Now in this lecture we are going to study about the electric field on the point on the equator. So consider a dipole plus q and minus q. This is its center. From the center we will take a point P. Point P from the center of the dipole. The length of a dipole is 2a. So from the center we have taken, so both the sides there will be the distance a and a. This point P from the center we have taken, so its value is r. Now from the Pythagoras theorem you know that this line joining point plus q to P and minus q to P will have the distance of root of r square plus a square using the Pythagoras theorem. Same way here also, root of r square plus a square. The field produced due to this, here E, due to this one, this will be E plus Q, and here E minus Q. Clear? Now we are going to write the value of E of due to plus Q charge and due to minus Q charge. So E plus Q will be equal to, you know the formula of E, that is electric field, kq by r square. Here the distance r is root of r square plus a square. So the whole square of root of r square plus a square, that is q upon 4 pi epsilon 0 r square plus a square, and the unit vector p. Same way E minus Q will also be equal to Q upon 4 pi epsilon 0 r square plus a square into unit vector P. So this is E plus Q and E minus Q. Now we have to write the whole E, that is electric field. E will be equal to, here you can see that the direction is opposite, right? So it will be minus of E plus Q plus E minus Q cos theta. This is the electric field in this direction. Now why here negative sign comes? That is, I said, due to the opposite direction. We know that in a dipole the charge passes from negative to positive. So what is the direction in dipole? That is minus to plus. Minus to plus. And here the field produced will be is in this direction. So they both are in opposite direction. So that's why it is minus of E plus Q plus E of minus Q cos theta. Here cos theta, we know from the trigonometry that what is cos theta? That is adjacent by hypotenuse. Here our adjacent is A, our hypotenuse is root of r square plus a square. So what is the value of cos theta? From here, cos theta equal to A upon root of r square plus a square. We will substitute this value of cos theta here. So we will get minus q upon 4 pi epsilon 0 r square plus a square plus q upon 4 pi epsilon 0 r square plus a square into the unit vector p. Cos theta is, what is the value of cos theta? That is A upon root of r square plus a square. here you know this is r is root of r square plus a square, k q by r square. So this root and square cancelled out and we get r square plus a square. Now E will be equal to minus. We will take q upon 4 pi epsilon 0 r square plus a square as common. So we got 2 minus 2qa upon 4 pi epsilon 0 r square plus a square raised to power 3 by 2. How 3 by 2? Here we took common r square plus a square common. So r square plus a square into root of r square plus a square, this one. Here power is 1 and here power is 1 by 2. 1 plus 1 by 2 is 3 by 2. So r square plus a square the whole power 3 by 2. That is 2aq upon 4 pi epsilon 0 r square plus a square the power 3 by 2. We have solved this also. Now we know that if this point P is at infinite distance or at very large distance, that is r is very much greater than a, then we have to ignore this a and we will get minus 2aq upon 4 pi epsilon 0 r square raised to power 3 by 2. 2 cancel out. So we got this one. We need to write unit vector p, that is minus 2aq upon 4 pi epsilon 0 r cube. So this is the formula of electric field of an dipole at the equator. Clear? We can substitute the value of 2 at the place of 2aq. We can write electric dipole moment P. So it can also be written as minus kp by r cube. You know that k is 1 upon 4 pi epsilon 0. So this is the derivation of electric field of an dipole at a point on the equator. The physical significance of dipole. The center of the positive charge and negative charge of a dipole, they coincide with each other. So such kind of molecules are CO2, CH4, etc. Such kind of molecules have their positive and negative charges coinciding with each other. So when the electric field is applied at that point, at that time only, they possess the dipole moment. But for some molecules such as H2O does not have their positive and negative charges coinciding with each other. So such kind of molecules are known as polar molecules. Polar molecules, and they have the permanent dipole moment. They have permanent dipole moment in presence or absence of electric field. We have studied about what is dipole, what are the physical significance of the dipole, what is the value of electric field of an dipole at a point on axis and on equator. Now the next topic comes is the dipole in a uniform field. So when a dipole is placed in a uniform external field, how it behaves. So consider a dipole having the angle theta, which is kept in a uniform external field. Now this is a dipole having minus and plus charge. You know the direction in the dipole is from minus to plus, means in this direction. When it is kept in a external electric field, it aligns its permanent dipole moment. When a dipole is placed in a external field, it possesses the dipole moment. So the dipole moment P and external field E comes in parallel with each other. So for that, the force minus QE and plus QE, both are the same forces, equal in magnitude and opposite in direction. One force goes in this direction and second one in next direction. So this is known as the couple. This is known as couple. Two forces which are equal in magnitude but opposite in direction are known as couple. So it will align with each other. So when it is placed in an uniform external field, then at that point the net torque acting on this couple will be equal to 0 and the net force will also become 0, and we will have the value of torque, that is tau. We will have the value of torque tau equal to P cross E, where P is the dipole moment and E is the field. So tau equal to, here there is an angle theta, tau equal to PE sin theta. Whenever there is cross, we write sin theta. When there is dot, we write cos theta. So tau equal to PE sin theta. Now what if the dipole is placed in a non-uniform field? When a dipole is placed in a non-uniform field, then the net torque will be equal to 0, but there will not be the 0 force. The net force will not be 0, but net torque can be 0 when it is placed in a non-uniform external field. Now we will study about that when the dipole is has its direction opposite to the direction of the field or in the same direction of the field. The direction of dipole is opposite to the field, so we get the direction of net force in right side and increasing field also right side. In next case, when the direction of dipole and the field are parallel and in the same direction, then the direction of net force will be left side and the increasing field will be right side. So this is the dipole in a uniform external field. Now we are going to study Gauss law. Consider a sphere having the surface area S, radius R. So we will consider a small area delta S in this R. So the flux linked with it, phi will be equal to E dot ds. We know the formula of E, that is electric field of this sphere. Q upon 4 pi epsilon 0 into R square. What is delta S? Area of a sphere is 4 pi R square. 4 pi and R square cancel out and we get epsilon Q upon epsilon 0. So this flux phi equal to Q upon epsilon 0 and phi equal to E dot ds is stated by the Gauss law. There are different criteria for the Gauss law. First of all, it is only true for the closed surface. It is only true for the closed surface. Second one is, it only considers, we need to consider only the charges which are enclosed in a closed surface. So the charges which are inside the surface are considered, and the charge which is outside the surface, closed surface, they are not considered. Only the charges inside the surface are considered. Gauss law is dependent on inverse square law. Inverse square law. Gaussian, the surface which we take for this flux, that surface is known as the Gaussian surface. We can take any surface as the Gaussian surface, but it should be continuous in nature. The continuous charge distribution buted surface can be taken. We cannot take discrete charge in the Gaussian surface. So we need to have continuous charge. Distributed surface. Now in next lecture we are going to study about the applications of the Gauss law.